So linear equations can be represented in several different ways. Let's list some of the ways. One of the ways is in the word itself. So we can represent a linear equation as an equation like y equals mx plus b. We can also represent it using an input-output table. And we can also represent it using a graph. So let's talk about the input-output table and the graph way of representing them. So the next line says, one convenient way to calculate values is to use a t-table, which is synonymous with input-output table. You can use either one. Can you identify the pattern below and find a linear equation in two variables that represent this table of values? So first off, I just want to label the columns and say the left-hand side is the x column and the right-hand side is the y column. Now, what is the pattern here? So notice that as I'm increasing the x value by 1, I'm increasing the y value by 3. So hopefully you can see that pattern. As I'm adding 1 on the left side, I'm adding 3 on the right side. But notice that in this next value where I want to fill in this blank, notice that it jumps from 3 to 8. So it's not following the same pattern. So I would have to add 3 multiple times. So note that this is jumping up by 5. So that means basically one way that you could think about it is that I would need to add 3 5 times. Or another way of going about this is we can form a linear equation. So remember, a linear equation is y equals mx plus b, where m is the constant rate of change. So notice that every time we increase our x value by 1, we're increasing the y value by 3. So that's another way of saying that our slope, the numeric value of the slope, is 3. And if we want to figure out what the b value is, the b value is the y value when x equals 0. So notice that that's the first row in this table. The x value is 0 and the y value is 1. So that means that our b value is going to be 1 here. That makes things a little bit easier for us to calculate these 3 values that are blank here. So let's use our equation to figure those out. I'm going to plug in 8. So 3 times 8 plus 1 is 24 plus 1, which equals 25. So that's the value that I'm going to put here, 25. And notice we would have gotten the same thing if we added 3 5 times to the previous value of 10. But that makes it a little bit more challenging when we have decimal values like the next one. So that's why we want to use our equation again. So let's plug in 3.25. So 3 times 3.25 plus 1. So if I throw in 3 times 3.25 into my calculator and then add 1 to it, that gives me 10.75. And then last one, I'm going to evaluate our equation when x equals 1.7. So that is going to be 6.1. Okay, so the next line says, could you graph your data points? And we might need to change the scale first. So here's our XY plane. So I'm going to label my axes. This is Y and this is X. So just for the sake of time, I've gone ahead and I've filled in the X scale and the Y scale. So the X is going by 1s and the Y scale is going by 4s. And I want to plot my points now. So 0, 1, that means that I'm on the y-axis and I'm going up 1 unit, so that would be like about right there. If I plug in 1, my output is 4, which is right there. If I plug in 2, my output is 7, which is right there. And if I plug in 3, my output is 10. And then if I plugged in 8, my output is 25. So that's about right there. And I can definitely connect those with a line. Okay. So I've gone ahead and I've connected those, and I'll just put arrows to indicate that they go on in both directions. So that is how we would have represented that equation with a line or a graph. So recall that the equation was y equals 3x plus 1. So this is the equation representation. This is the graph representation. And then we saw the table representation a little bit earlier.